looks pretty.
Recording.
Hey guys on Blue Jeans, can you hear us?
Yes.
So my name is Yogesh, and hello. My name is Yogesh, and I am an engineering manager here at LinkedIn, working on the AEM platform. And I would like to welcome you guys on behalf of LinkedIn AEM team, LinkedIn, and now Microsoft. So before we start, I just want to go through some housekeeping stuff. Like, we do have food back there, drinks. The restroom is straight and to the left. We do have pizza coming as well at 7 o'clock, so stay around at least till 7. So before I hand off to the next speaker, I just want to give a little bit history on where we were like 4 years ago and where we are now, and the way we are using AEM here. So, I mean, 4 years ago when this project started, LinkedIn was still like kind of a startup. And then we had our sites, which we actually use AEM for right now. I mean, to be clear, we don't use AEM for LinkedIn.com. We use AEM for all the other microsites, which we call it, which comms and other people uses for like internal and external communication. Through that, we get more than millions of requests a day, like including both internal and external microsites. And we do have more than 100 of internal and external microsites that we host using the AEM platform. So back then, like 4 years ago, we had our site hosted on WordPress, and as if you have worked on WordPress before or any PHP stack, you know that how easy to hack that shit. And that's what happened with our sites as well. And that was one of the driving factors why we actually onboarded AEM to this company. We started with very basic implementation of AEM. Back then we were using CRXD to actually do the compilations and everything. That's sucky, but that's how it used to work. And we used to do the deployment through CRXD on production instances. So you can imagine how often our site used to break. But since then, we came a long way. The LinkedIn philosophy is actually, LinkedIn is member-first company. So the member data, securing member data and keeping their privacy is really, really important to LinkedIn. It's good in a way that we provide a very intuitive and amazing experience to LinkedIn member, but it's not good for third-party softwares. So it provides a lot of limitations if we are using any third-party software. AEM is one of them. So other companies, like, they do have a privilege to use a lot of cloud-based software for their need. For example, for analytics, you can go ahead and use like Google Analytics or Adobe Analytics solutions. For deployment and all, you can use Jenkins or other Bitbucket softwares. For monitoring, you can use other software. For GMX monitoring, you can use other software. But with LinkedIn, using cloud software is kind of a no-go. So in this talk, we are going to talk about how we use current LinkedIn infrastructure that amazing engineering team in LinkedIn has built for anything, starting from like doing the coding to the deployment to the monitoring and even doing the personalization and everything with AEM stack. So the one thing I want you guys to get from this talk is, if you have like good infrastructure within your company, like you have a good engineering team, you can integrate AEM with any other softwares within the team to actually achieve your need. With that, I'm gonna give this to Bo and Apaji to talk about how we use AEM at scale here at LinkedIn.
Thank you, guys.
Thanks, Ruby. All right, everyone. My name is Bo, and this is Apaji. Both of us are backend software engineers on the CMS team here at LinkedIn. So in this part of the talk, we're gonna give you a high-level overview of how we here at LinkedIn leverage AEM to empower LinkedIn communication and marketing sites at LinkedIn scale. So at LinkedIn, we leverage AEM to empower our communication marketing sites like business.linkedin.com or learning.linkedin.com. So the previous one is, can you go back? Yeah, so this is a screenshot of our business.linkedin.com, and the next slide is a screenshot of our learning.linkedin.com. And those beautiful sites are empowered by AEM. So behind the scenes, our work on top of AEM follows this typical development cycle. So there are a few phases, from develop to build, test, deploy, and monitor. So develop is the phase where we implement LinkedIn-specific features on top of AEM and integrate that with LinkedIn technologies. Build is the phase where we generate artifacts. Test is the phase where we assure quality of our artifacts. Deploy is the phase where we install our artifacts to production instances. And monitor is the phase where we watch the performance of our sites. So in the rest of the talk, we're gonna cover these topics one by one. So we're gonna start with develop, and Apache is gonna talk about the develop part.
Okay, so when it comes to development on AEM, we start with developing templates. We start with developing components on AEM. So that's typical AEM development environment. What else we need to integrate with that LinkedIn when it comes to leveraging the LinkedIn stack? One of them is integrating with member data. So we use LinkedIn OAuth to integrate and retrieve the member data for authorization purposes. So this can be any app external can be integrated with LinkedIn API to be able to provide an option for users to log in using their LinkedIn login and then access restricted access. So you can find more information on OAuth on developer.linkedin.com. That's a very good resource for visiting to know more about OAuth. Basically, we use two-legged OAuth to retrieve member information and use that information for personalization. So when it comes to personalizations, two aspects that we need to provide for personalization. One is creating experiences in AEM, which is basically what we display for a user, and creating segments, which is basically defining the audience, the type of audience, and based on the audience, type of experience that they're going to get. That's the customization, which is LinkedIn experimentation that we did here. And segments is one we are customizing based on OAuth as well as member data. So we have LIX to define based on the member information what to display in AEM. In addition, tracking. Tracking is the key piece for us to be able to see how the application is behaving and then tune back. So with respect to tracking, if you are familiar with LinkedIn technology that is used for tracking, real-time user metrics around similar technologies. You can find more on emulating.linkedin.com website about how LinkedIn uses run as well as other tools for tracking purposes. And in our case, for microsites, we are using client-side page events to trigger data for us to Kafka. And the data is used by HDFS to give us some metrics for tracking purposes and as well as tuning. And another integration or customization that we did on AEM is forms. So when we started with AEM 5.5.561, forms was the key requirement where we should be able to support authors being able to create forms on demand, as well as support I18M for forms, being able to integrate with a LinkedIn API. So contact us form, you don't need to type in your information, you can log in and auto-fill the information into the form. So we have the integration and custom framework created for forms. And that's one of the sources for lead generation. So these are the 4 aspects, high level, we try integrating with existing LinkedIn stack as part of the development. Moving on to the next step, who is going to?
Yeah, so the next phase is build. Just to recap, build is the phase where we generate artifacts. And there are 2 types of artifacts we generate typically. One is bundle jar files. 2 is package zip files. In terms of the build automation system we use Gradle as opposed to Maven. One of the primary reason behind that is that Gradle is the recommended build system here at LinkedIn. So it fits really well into the LinkedIn toolchain. And that's what we want to get ourselves onto as well. But there are a few benefits that we get by using Gradle for building AEM artifacts. One is that Gradle build scripts are concise, they are really short and very easy to understand. 2, they are very extensible and programmable. So if you want to override some of the default behaviors of the tasks, you can easily do that just by writing some Groovy code, just as you would do in some other scripts. The third thing is that Gradle project structure is very much flat. It's not like in Maven where hierarchical structures are allowed. But here it's very flat, so it's easy for you to manage the projects. To be able to build those artifacts, the bundle jar files, the zip files, we need to use Gradle plugins. We rely on third-party open source plugins for doing that because no other team at LinkedIn have done this before, and we don't want to reinvent the wheels if there are resources out there that we can leverage. So we actually pick the Gradle plugins from Time Warner Cable. They have 2 very good plugins, one for building AEM bundles, the other for building AEM packages. Yeah, so both of them are great. We can use them out of the box. They fit our needs very well. Only one exception to that is the package plugin, which allows only including jar files in the install folder. So in our case, we want the bundle jar files to be installed on publish and author instance differently. Some of them we want them to appear only in author instance, but not publish. Some others appear only in publish, but not author. So we needed to be able to let us put bundles under install/author and install/publish. So we had to write our own extension of the tasks from that package plugin, and that worked out pretty well too. So again, that also shows how powerful Gradle is in building AEM related stuff. The next bullet we want to talk about is Java 7 versus Java 8 environment. So Apache is going to talk about that.
Yeah, with respect to build, we recently migrated to Java 8. When we compile the code, we are okay. There is no issues with the code other than a simple target type inference change. But the key piece is generating the service descriptor files that are deployable on Java 8 instances, which is where, again, the TWC plugins that Bo talked about that we customized to support install and author and publish. So those are the aspects that we need to customize a little bit when we migrated to Java 8. With respect to build. So let's move on to the next phase of the life cycle.
Yeah, so the next phase is test. So that's where we make sure that the quality of the artifacts are good. Right? So we do run tests at different phases of the development cycle, so it's actually everywhere. Very first is Java unit tests. That's pretty typical. So we have Java unit tests as part of every bundle that we develop, and we enforce code coverage on those bundles when they build. The next one is JavaScript unit tests. That's something that probably other AEM projects don't have. So in our build, we also make sure that our JavaScript unit tests are run and pass. And later in another part of the talk, Varun and Gladden will talk about more details on this aspect. The next one is integration and Selenium tests. So these are the tests that we run every time deployment happens. So we run integration tests and Selenium tests against our staging and production instances after deployment. So integration tests are there to make sure that all our servlets are running correctly, all the services are running correctly, and all the pages are returning the right responses as expected. And Selenium tests are there to ensure that the interactions on those pages and sites are as expected. Right? Another tool that we have and we run every time deployment happens is Visual Diff. So this tool is to detect the difference between this build and the previous build in terms of visual appearance. So this is to make sure that there's no unintended differences. If there are, we may need to look back and see if any changes break what we wanted. So that's about testing. And the next phase is deploy. So again, deploy is about installing artifacts to our production staging instances. And Apache is going to elaborate on this infrastructure of how we deploy our artifacts.
So when it comes to infrastructure, if you look at this deployment diagram, it's a typical AEM deployment diagram where we have author instance for creating content and publish the content to publish instances and cache the static content on dispatchers. What do we need to do differently at LinkedIn? One is AEM is third-party product, as you mentioned, and there are security concerns about deploying third-party products on LinkedIn along with LinkedIn applications. So one of the options that we addressed it with is by creating a DMZ zone for third-party applications. So all the AEM application instances are in a DMZ with a controlled access, and using ACLs, the access from AEM instances to other applications is controlled. The next big thing is scalability and maintainability. How do we make sure that we are able to address the increase in traffic, as well as address the failovers, as well as improve the response times? So if we take each aspect, one is addressing the increase in traffic. So LinkedIn has a dynamic host deployment system that's built in. So it's basically a group of hosts available as pool, and when there is a need, if our application is a LinkedIn compatible application, it can deploy that application automatically to the host based on the increased traffic. So recently we were able to achieve that almost by making AEM application as compatible LinkedIn application so that we can deploy dynamically. Maintainability, failovers. So you can see here we have multiple data centers to address the load balancing need. And in front of the data centers, we have the Apache traffic server as proxy server. If we are familiar with how LinkedIn is able to address and improve the response times, it's basically using POPs, point of presence. What it basically does is there are multiple POPs throughout the world, and based on user location, a nearby POP is resolved, and the POP is going to forward the request to data centers. In our case, it is dispatchers. So that by using POPs, we are able to minimize the network latency by finding nearby data center and sending the content back to a user from the nearby data center. And also we have CDNs on top of the dispatcher caching, so all the static assets are cached on CDN as well. And also from the application perspective, it is stateless, which is basically mean we can cache as much, and only the dynamic content requests will be forwarded to publishing instance. That's how we were able to minimize the load onto publish and support the increasing traffic and cache at max on dispatcher. That concludes about the infrastructure. Now Bo is going to elaborate more on how are we deploying the applications.
Yeah, so the typical way of deploying AEM packages or bundles is through curl commands. But in our case, we don't want to do that because we don't want to expose admin password in plain text in our build scripts. And also we want to be very much consistent with what the rest of LinkedIn engineering uses in deploy. So the way we deploy is that we actually leverage the hot deploy feature of AEM to make it happen. So what essentially happens is that we copy the package zip file into the install folder of each AEM instance. And it does not matter whether it is a published instance or it is an author instance. It works very well, so the AEM instance will detect the change in the install folder, and it's going to install the AEM package. And then all the bundles will be reloaded to get the new versions of them. Typically, it takes less than a minute for all the bundles to be refreshed and become more active. But of course, there is this short period of time where they are not fully active, and they might not be responding correctly. And that's why we have implemented this health check feature where the published instances will be able to scan over all the bundles and see their status and let the dispatcher know whether they are ready or not. And so before they are ready, they would let the dispatcher not to forward the traffic to those published instances. But once they are ready, meaning all the bundles are active and responding, it's going to let the dispatcher know, yeah, you can start forwarding the traffic to me. And that's essentially taking boxes or published boxes out of rotation or back into rotation. Right? So the next thing is rollback. Yeah, so at times there is the need for rolling back your releases. And it is the reverse process of deploy. Since we use hot deploy for deploying, it also makes natural sense to utilize this again for rolling back. So what happens when we do rollback is essentially that we remove the current version of the package that we have copied into the install folder of the AEM instance. And then after that, we copy again the earlier version of the package into the install folder. And that would make sure that the AEM instances will roll back the package into the previous version correctly. Another thing I want to talk about is canary. So in our published instances in production, we have this concept of canary, where we sort of deploy to certain boxes before we deploy to all the other published boxes to make sure that, oh, it works well as expected on a limited boxes. So for the canary part of it, it's not just one published instance. It's a combination of a published instance and a dispatcher instance. So in each of our colos, we have a dispatcher instance and a corresponding published instance, which together form a canary instance. So then at that point, you may have your release pushed to those two boxes, and you can test just on those boxes to make sure that they are working correctly as you expect. And then you can push your release to all the rest of the boxes in production. All right. So next phase, and the last phase, but not least, it is monitor. So this is to watch the performance of our sites. We want to make sure that the sites are performant. So a few things we do on that front. The first thing we do is collection of performance metrics. So we define performance metrics in our Java backend. Some of them are about like the performance of the components, the servlets, the services, and also about the hardware boxes and all the bundles. Right? And then we use JMX, which is out of box with AEM, for the collection, and then we send them through Kafka to our LinkedIn tool called Ingraph, which is a tool for visualizing performance metrics. So by watching those graphs, we will be able to tell like how the performance metrics change over time, especially during deployment time and after deployment time, right? And then we set predefined thresholds to get ourselves notified, alerted when things go wrong. For example, errors go beyond certain, say, 10 times each per second. Right? And in the meantime, we can also define that as an aggregate over multiple colos, over different tags of products. Yeah? And after that, so in the meantime, we also do regression detection. So LinkedIn has good tools for detecting regression. So at the time of deployment and after that, we get on those tools and see how the performance of the sites compare to, say, last week before the deployment. If there are changes in those, detection, regression is detected, and then we take action. So then we go back to our develop cycle to look into the issues and fix them. So yeah, so that well covers all the 5 phases that we wanted to cover as part of our development cycle. And we are ready to take questions if you have any.
Oh, you may want to.
Oh, sure. Am I not loud? So first question is, why do you prefer bundles and packages separately as opposed to just using the JCL installer? You said you have 2 different Gradle plugins, one would deploy just the bundles and another deploy the content package.
No, it's mostly building the bundles, not deploying. Deploying is single package.
Oh, so you're not actually deploying them as part of it. Okay,
yeah.
Got it.
So yeah, so as I said, Gradle supports this multi-module project structure. So in our case, every Java bundle is a sub-module of the project, and it comes with its own build script. And that build script uses the Gradle plugin for building the bundle. And then we also have another sub-module, which is for generating the package file. Example?
And then, was the picture that you showed up there just an example of when you said single author instance in production, publish, 1 dispatcher for each publish, and then Apache traffic server? How many publish instances roughly do you actually have?
So yeah, so it's 3 instances per data center, and it's not one-to-one, it's one-to-many. So one dispatcher can send requests to all the publish instances.
Gotcha.
So it's just the diagram, not depicting it, but that's how we have.
Roughly how many data centers, like ballpark?
Right now 2, and we're going to 3 and 4.
Gotcha.
Yeah.
And then my last question, and I promise I'll shut up. You mentioned the health check. Is that just like an Apache module that you wrote for the dispatcher to check the published bundles to make sure that they're all active? Or? I didn't catch exactly how that works.
So basically we are using dispatcher failover mechanism over there, and the health check on publish instance, health check URL and publish instance is going to be our key for determining its health. So on failover, you can specify the URL that dispatcher can ping. So if there is a 500 error from publish instance, obviously dispatcher is going to ping the health check URL, and if health check is response back with 500, then dispatcher automatically stops sending requests to publish instance.
Gotcha.
Just to that one.
A question. I think it's just clarity around the scalability pieces that you were talking about. And then, so as you're scaling additional, so you have these sort of clusters, right? So you get 1, two pubs to two dispatchers. So do you have those sort of segments just sitting there, and then you're just like plugging them in
So
to a load balancer, or are you physically just spinning them up dynamically?
it is not physical. So it is basically we are leveraging LinkedIn infrastructure itself, where there are predefined hosts in a pool sitting in the data center. And if there is a need for a new dispatcher, it is going to be spinned up automatically, because we are, the AEM application itself is embedded into a LinkedIn standard infrastructure product template. So the AEM application can be deployed using standard LinkedIn tools to any host. So let's say if we need to spin up a dispatcher, it is basically copying the Apache module and dispatcher module on top of it, and then applying the config on top of it.
It's just dispatcher, it's not published that you're
No, not published. The publish obviously it's a licensing involved, so it's not published.
Okay.
So that's why we want to make sure our application is stateless, and we can leverage caching and dispatcher as much as we can. So it's not published.
Okay, makes sense. Thanks.
I'm just curious, you know, I'm a regular user of LinkedIn. What part of LinkedIn is actually being served through AEM as opposed to a lot of the dynamic stuff that's there?
Yeah, so earlier, I think in the beginning of talk, oh, you were not here. Yeah, so we showed a few screenshots of those sites that we empower using AEM. Examples are like business.linkedin.com, learning.linkedin.com, veterans.linkedin.com. Those are all for marketing and communication purposes, not the www.linkedin.com that have the dynamic content.
Oh, got it. Thank you.
Every other subject that's not www is basically the microsites, through AEM.
Huh? Oh yeah, so yeah, later you will hear part of the talk elaborating on how we use AEM to empower even internal sites that are used by internal authors and an internal audience.
First, I'd like to say thank you for sharing this information with the community. This is something some other people can't do easily. I have a couple of questions. So you have this multi-data center. Some of the challenges we've had in the past is replication might fail. How do you ensure that when content gets replicated, that all of the different instances, get to see the same thing, and people are not seeing this inconsistent view of the content? That's one question.
Okay.
Second one is, in terms of, you said deployment of your artifact, and in that case, how come you guys haven't had a chance to, or explore Jenkins or something like that, which can, essentially, DevOps can just run the job and then does that for you? Is that something that you couldn't use because it's not some tool that LinkedIn?
We're actually using that, but so I'm going to take the second question first, and later I will let Apache address the first question. Sure. He's the one who takes care of all those content migration thing over the weekend. So yeah, for the second question, for Jenkins, yes, we do use it, but it's wrapped by our great LinkedIn tools team, which sits in this. They take the entire building, this building. So they have built great tools that are very much unified across all the LinkedIn engineering team. And for us, we don't need to worry about Jenkins because it's there. They are using Jenkins, and they have lots of hosts that run Jenkins jobs at all times. So the entire the infrastructure that we have been using for building, for monitoring, all those stuff, the effort was to get ourselves on the LinkedIn tool chain so that we can leverage what they have provided instead of us managing, say, our own Jenkins server. So yeah, so after all the migration work we have done, we are now almost 100% on LinkedIn tool chain, and that makes our job much, much easier.
I mean, it's actually better than what a lot of templates are using, because it's not the way that you were just having a big copy, it's all automated. So it's click and play. even we can do an automation,
Right.
it's continuous delivery. Like we push
Right.
the code and we'll get it.
So as a developer, basically my job is to check in the code, and then after that, I'm not saying that I'm not testing the code, but once it checks in, it goes through the pipeline by itself. It's all taken care of by the great tools that we have. I'll let Apache take care of the first question.
With respect to content sync up not happening, so we didn't run into that issue as often, but typically the source of truth is lying on agents on author, right? So we can find that information on author to make sure the content is published to all the replication agents. That is one source of truth that we can leverage to determine whether content is synced up or not, or if there is any blocking queue with respect to replication, and trigger that. I mean, that as our triggering point to see which one doesn't have a content synced up, and taking it out of rotation and make a debug.
So you have like one agent per publish, is that essentially?
Yeah, as of now, yes. Thanks everyone. I think we're going to hand it over to Warren and
just one quick question. Wanted to understand, do you have a Mongo MK or a Tar MK?
Oh, it's Tar MK, it's not Mongo.
Okay.
We tried with Mongo MK for some time, but since we don't have a DevOps support, we don't want it to have anyone supporting Mongo. Because now we have to support two applications, Mongo and AEM, right?
Okay. Yeah, not only that, our use case is not require Mongo. If you go for clustering and if you need a sync up need to happen on multiple instances, that's where you go for Mongo. I don't think there is a need for this.
We don't have something.
Right. All right, cool. So we're gonna pass it on to Gladden and Varun for the next part of the talk.
Thanks everyone.
Okay.
Okay, apparently pizza's here.
Nobody
Yeah, if anybody wants to help themselves. Here you go, Josh. Okay, so here I think everybody here is familiar with, being familiar with AEM. They're familiar with the concept of components, and AEM really has like a strong sense of components, right? So essentially modular units on a page that provide specific functionality that you can string together in order to generate an entire page. And the component architecture is very well laid out. And if you look, and this is evident when you see, for example, this is a just a sample page. And in AEM, there's a sense of components where, for example, this is the banner component, and the sidekick has a sense of components in that it lists all the components for you, and it highlights shows you the ones that you can drag and drop onto a page. And we see this something similar with the backend side of AEM as well, with Sling, for example, where there's, you can have a component and it has a certain resource type. For example, in this case, it's resource 1, and let's say you have another couple components. This one has a parent resource type as well, and then let's say we have another third component, and it's of resource type 3, and all of these can be strung together in order to generate one page. But what about JS, right? AEM, as far as we know, doesn't really provide a strong sense of components for the front end. And you might say, well, what about client libraries, right? They come to the rescue. You can separate your code out via the client libraries and then include them onto the page, and all is well. But when you end up using client libraries, you might end up getting codes that look something like this. You have thousands of lines of code, and it might not necessarily be, you might not have code separation there as much as you want. And then so you might say, oh, well, what about Webpack or Require or any of the other sort of JavaScript bundlers that you can use in order to create JavaScript modules on your page. And these are all really great as well. So you get the code separation that you can use in order to instantiate separate modules on the page and use them as need be, and you can get the dependency management as part of it as well. But the issue still is each one of those modules, once they get included on a page, you essentially have one giant file of JavaScript, and when each one of these modules executes, each of the modules is responsible for their own, for example, DOM manipulation or event bindings or anything like that. So you kind of run into the same issue where each module is responsible for its own sort of setup and teardown. And so that's kind of where where we come in, and that's what we were going to focus on. So I'm Varun, and this is Gladden, and we're both UI engineers here at LinkedIn, and we're here to talk about customizing AEM's front-end architecture. So Gladden's going to start us off with the first topic.
Hi. So let's talk about component instantiation in the front end. This is a typical scenario, page loads, you see the DOM, the DOM content loaded event fires, and that's when your JavaScript starts executing. So say for example, over here we have foo, bar, and baz, these three modules that are going to run one after the other. Say foo is running right now, and it's foo's responsibility to find out what part of the DOM it's responsible for. So it needs to query that part of the DOM, act on it, do some event bindings, make some DOM manipulations if required, and similarly, bar acts after that, baz acts, and it's all good. It sounds fine, right? But what about Ajax, right? We load some new content in, and now the DOM has changed. What do we do now? How do we make sure that we reinitialize or rerun the JavaScript for this new DOM that was or part of the DOM that was that we dynamically got in? So you might say, let's rerun the JS or write the JS in such a way that even if it runs twice, we do some cleanup and remove the invalid event bindings, and have new event bindings and do the DOM manipulations again. But in this way, what you're doing is you're giving the responsibility to do that to each module. So when you're writing JavaScript for a particular component, you give the responsibility of figuring it out to the component. And as you can see, it's starting to look like spaghetti, right? So you don't know. So what we identify here is it will be really good to have a nice framework for encapsulating components on the front end as well. For Sling, you have a clear separation. There is resource type, and then on the back end, you have models, Sling models, or WCM use classes that are associated with a particular component. So what we did was use the same model even for the front end. So what we introduced is for every component, we added a label to the markup that is generated, or like the container that is generated. We added a component JS load path data attribute and marked it with the component name or the resource type that it belongs to. How does this help us? So going back to the same problem that we had before, now DOM looks slightly different. It has containers which are clearly separated, and it has labels associated telling what part of the DOM belongs to what component. How does this help? So there's a DOM content loaded event, and we introduced something called app loader. What does the app loader do? It calls the component loader which basically looks for these chunks of DOM which are already on the page, and it iterates through them one by one. It takes a look at component JS load path, and feeds only that part of the DOM to the associated module. And similarly for bar and baz. This all looks fine, and you know how this is going to help us? If you go to the next slide. See now, your page has loaded, all your JavaScript has been instantiated, and now some new content comes in via Ajax. So we have the component loader listening for a for a component load event, and once that event is fired after Ajax config, you need to explicitly fire it, and it goes back and scans the DOM again for any new components that have been added. And we have a clear chunk of DOM that we need to feed in, since we have the label associated with it. Say in this case, a new component foo was added, right? So we know that from the attribute, and we are going to feed the same DOM, only that part of DOM to its respective component. Yeah. So what are the oh, let me show you how it exactly looks like. So over here, the component foo, we have the class foo, and we have the constructor and different methods, and we are exposing this one method called scope in it, and that's the method that the component loader is going to use in order to scope in it that part of the component. And this is what the component loader looks like. Take a look at the init method here. We are adding an event listener which listens for the component load event, which is fired every time we bring in new components via Ajax, and it triggers the load components method, which queries the DOM for all such data component JS path instances, and then it feeds them one by one to their respective components. We'll share the slides so you can take a look at it. So what benefits does this offer to us? The first benefit is spaghetti-free code. So we have a proper framework to write, to encapsulate front-end components similar to back-end components. Next one, the way we do experimentation here in LinkedIn, we have our own engine that tells you what experience to serve, and we don't render that on the back end. So we do all of that on the front end. So that's why we need to dynamically load components, and having a nice framework to encapsulate components even on the front end helps us use our experimentation framework. And unit testing. Yeah, so since we have proper encapsulation of what DOM corresponds to what component, unit testing is JS unit testing becomes really easy. And since everything is modular, it becomes really easy. So talking about unit testing, Varun is going to talk a bit more about how we do JS unit testing.
Sure. So when you think of unit testing, right, you usually kind of have to step back and see what does unit testing really provide us, right? And I think this sort of comic sums it up really well, which the gist of it is, QA is the main goal, right? You want to be able to test all of your code in the most efficient way, essentially with the least amount of effort, such that you have confidence in your code that you can deploy to prod. And that in and of itself is a very noble and good goal to have. But then if you layer unit testing, or if you layer things like, for example, going back to what Bo was talking about, things like integration testing on top of unit testing, and then functional testing and also acceptance testing with the visual diff tools that we have, you can sort of ladder up to something really awesome like continuous integration or continuous delivery, depending on how far you want to take it. And that's really awesome because then as a developer I can just code whatever it is I want, build, and then as part of the build it will run the suite of tests, and then the tests will pass, and if they do, then it will automatically get put into the development pipeline, and then as Bo was saying, the build process kicks off, and then it starts deploying to whatever it is, whichever environment it is that we want it to go through the stages, for example, staging and then on to prod. So having this sort of setup is really awesome, and the foundation of it is essentially unit testing, right? So how does unit testing normally work in industry? So you essentially have mock data, and you combine that, especially with JavaScript, you sort of need access to the DOM, so you have some sort of template as well that you need to interact with, and you essentially pass those both those things off to some sort of template rendering engine, and out comes a fixture. And then you have your unit test that can use that fixture and run against it so that you can verify the changes that you've made on the code that you're dealing with. So this looks fine and dandy, and it works really great for a lot of stacks that are out there, right? Let's say like React or Ember or any other stack that you're probably on. But one problem here is that since we're on an AEM platform, the issue is the template and the template rendering engine are encapsulated within AEM. And so it becomes difficult to render your fixtures offline, essentially, without a live running AEM instance. And so how do we sort of go around this problem so that we can have a, essentially, ideally, ladder up to a continuous integration setup, right? So the way we've sort of solved this is we have our JSON mock data as per usual, and what we do is we pass that off to something called we created a mock resource renderer, which is essentially a service that proxies requests between the AEM internals. Essentially, in this case, it takes the JSP, and if you know, as an example, we want to use JSP as the templates. It knows from the mock data what JSP it needs to render, so it pulls that in, and then it sends it off to the template rendering engine, which then gives it back the input. And so let's keep in mind that this is all within the context of AEM, and as that happens, then the mock resource renderer spits that code back out as an HTML fixture that unit tests can then use. So let's take a look at what this mock resource renderer is all about, right? So if we take a look at the code, the biggest piece of the mock resource renderer is this Sling request processor that comes out of the box. And this is essentially a window into the internals of how Sling works, and is pretty much going to drive the entire interaction here. So like anything else, because the mock resource renderer is proxying requests, we essentially have to fabricate a request. So we set up our mock request in order to pass it in. And we also set up a mock response so that we can capture the result that we get from the process request. And then all it is we just call the process request function on the Sling request processor. And that fires off the internal mechanisms that would normally happen if you visited a page via Sling, except we are programmatically launching those. And in the end, you just capture the output that comes out of the process and spit it back out onto the page. So with doing something like this, essentially, we have to think about why do we have to go through all this process, right? And the biggest thing we get out of this is essentially maintainability. If you sort of think about how you create a component in AEM, the process is pretty simple, right? You just go onto a page, you open up the dialog, you open up the dialog, and out comes a component. And you can essentially now, with this process, just go to the JSON representation of that component, and this is your mock data. And you can just feed that directly into the mock resource renderer servlet, and dynamically generate how many ever fixtures you want. And the biggest boon of that is, for example, if you look at the same diagram, but then you add a few more different sort of sets of mock data and the fixtures that you're going to require out of those. So let's say unit test depends on multiple fixtures in order to run the test suite. This process is still going to work because regardless of how many changes, for example, you might have, how many variations in your mock data, or let's say you have, your JSP template changes at some point in the future, you don't really have to update any of your fixtures. Whereas, for example, if you were to store all of your fixtures in, let's say, hard, like static HTML files, and your template changed at some point, you would essentially have to manually go in to each one of those fixture files and update them. Whereas in this case, the mock data is still the same. You pass that into the resource renderer servlet, and it uses the template that's already been coded out as part of the template that you use to render the component originally on a page, and then spits out all of the HTML fixtures for you that your unit test can then go use. Which is, that's pretty much what we want to do, right? We want to scale as much as possible and take the manual work out of doing things like unit testing. So that's essentially it. Any questions?
In the case of mocking, are you guys just testing at the component level or at the page level in this case?
Yeah, so in terms of unit testing, we do it at the component level. So like Gladden was saying with the foo example, for example, let's say you have a component called foo, we have the one JS file that corresponds to that component. And so essentially we're unit testing that individually. So it's at the component level.
Any chance we can see a demo?
Yeah, if we have time at the end, we can definitely throw up a demo for you.
Questions?
Hi.
You again.
So you guys talked really nice about the problem of how clientlets get concatenated, and therefore you end up with this long blob of JavaScript. What about the CSS? Do you also? I know you don't. I mean, the CSS gets concatenated as well when you put it inside the client level unless you debug it. So, is that something you guys are looking at, or you just not care because it's CSS?
So we have a very similar process for CSS, but though because we use preprocessors, we use Sass. The way we structure it in the Sass is we essentially just have a namespace per component. So like, for example, in the banner case, you just have banner as the namespace, and and you have all your relevant banner CSS within that namespace. But then I guess like when it gets compiled out to regular CSS, it's all just one blob anyways.
So we don't have the problem with dynamic loading with CSS, right? So even if you load anything dynamically, you don't have to worry about reinitializing the CSS. The browser is going to take care of it on its own. So concatenation is not really a problem. Like reinitializing is.
Gotcha. And then about the component load event that you're listening for in order to load in whatever JavaScript you need as is specified by that data attribute you guys have. Is the responsibility to throw that component load event on the developer who creates the component, or is there something that's automatically like going to throw that component load event on something that gets added to the DOM?
So the responsibility is on the AJAX. So whatever component is, or say for example experimentation component, right? It is doing the AJAX call. So when the AJAX is done, I just need to fire this component load event in order to initialize any new component that has been that has been brought in using the Ajax call. You don't really have to specify what got in. You just need to fire an event saying component has loaded, reinitialize. So it's the responsibility of whoever is bringing in the dynamic components.
Gotcha. And then last one, only because it's near and dear to my heart, is the you mentioned that you switched over to doing client-side rendering of experiment like treatments that come back from licks. How do you avoid kind of like the flashing in of the content that will happen when you do that client-side?
You have a spinner.
Really, you just do a spinner and then.
Yeah, it's pretty. So we are not doing complete pages. Actually, we are doing on some instances, but we like to try. We want to try to avoid that. So I understand, flashing of content is bad, but we can't really avoid it in our case. So that's why for slightly better user experience, we have a spinner.
Gotcha. Thanks.
Anyone else? Questions?
All right, so I'm going to hand off to Paul and Ali.
So we actually have a few minutes. If you guys want to take a quick break, bathroom break, or grab some food or refreshments, please take a few minutes to do so.
Get that pizza.
Pizza in the back.
Yeah, it's pizza. It's slice of New York. So.